4, we start off with the same definitions that we already know. Nothing new about those. They tell me that sine is y over r, cosine is x over r, tangent is y over x, and then their reciprocals are still true as well. That cosecant is still the reciprocal of sine, so it's r over y. Secant is the reciprocal of cosine, so r over x, and cotangent the reciprocal of tangent, so x over y. What is different about this section as compared to the previous sections that we've been looking at with trig is that up until this point, we were only working in the first quadrant where x and y are both positive, and so that meant that our sine and cosine values were positive. Today we want to look at how we could find the 6 trig functions of any angle, not just one in the first quadrant, but maybe our triangle is in the second quadrant, and if that's the case, your x value would be negative and your y value would be positive. That would lead us to think that maybe we could get some positive and negative sine values as well, and we can. And so that's what we want to look at to start with today. So we want to start off talking about where are the 6 trig functions positive and negative. You actually already know where the 6 trig functions are positive and negative. No, I don't. Yes, you do. Because if sine is the same thing as y, and if you take a sine value like 1/2 and you find its reciprocal cosecant, meaning you take 1/2 and you flip it upside down, it doesn't magically become negative, right? The sign doesn't change. If you take a number and you find its reciprocal, the sign would stay the same, right? So if I know what y is, I also know what sine is, and I also know what its reciprocal cosecant is. If I know what x is, I know what cosine is, and I know what its reciprocal secant is. And then to find tangent, all I'd have to do is just y over x, and its reciprocal cotangent would be the same. All right, so let's start with y. Forget trigonometry for just a second. What is y in the first quadrant, positive or negative? Positive. So that means that in the first quadrant, y, sine, and cosecant are all positive. All right, so to go the rest of the way around the circle, we're going to abbreviate that a little bit. Instead of writing y and sine and cosecant, we're just going to abbreviate with an s there for sine and understand that it represents the y and the secant as well. All right, so what are we in the second quadrant? Positive. Third quadrant? Negative. Fourth quadrant? Negative. All right, so your y value, positive in the first and the second quadrant, negative in the third and the fourth quadrant, right? That will be the same thing then for sine and cosecant. All right, let's think about x. What is x in the first quadrant? Positive. So whatever x is going to be the same thing as cosine and secant. So let's abbreviate that with a c over here in the second quadrant. That c will represent x, cosine, and its reciprocal secant. So what's x in the second quadrant? Third quadrant? Fourth quadrant. All right, so again, x is positive in the first and the second and negative in the third and the fourth, and so that will also be the case for cosine and secant. All right, so then for tangent we're just going to do y divided by x, sine divided by cosine. So we're going to come over here and just say positive divided by positive is positive, and that will be the same for its reciprocal cotangent. Over here, positive divided by negative is negative divided by negative is, and negative divided by positive is. So now I know where all 6 of my trig functions are positive and negative. Okay? So I could definitely sit here and work that out, and it doesn't take that much time. But it would also be nice if there was some type of little mnemonic device that I could use to help me keep that straight. And so what we use is something called All Students Take Calculus. It's kind of like, please excuse my dear Aunt Sally, helps us remember order of operations. We're going to use the first letter, A, S, T, C. You could make up your own sentence for it if you wanted to. A is in the first quadrant, S is in the second quadrant, T is in the third quadrant, and C is in the fourth quadrant. And here's what that stands for. In the first quadrant, all of them are positive. See how all 3 of them were positive? In the second quadrant, only sine is positive. The other 2 were negative. Now, when we say only sine is positive, we're just looking at sine, cosine, and tangent. We're not saying that sine's reciprocal cosecant is negative. We're not saying that. But looking at the three main trig functions, sine, cosine, and tangent, out of those three, only sine is positive, and we're going to assume that their reciprocals follow suit and do the same thing they do. Okay? In the third quadrant, T stands for tangent. Only tangent is positive. The other two are negative. And in the fourth quadrant, C stands for cosine. Only cosine is positive, and the other two are negative. So that gives me, ASTC gives me a real quick way to be able to look and see what's positive, what's negative, and which quadrant instead of having to work all of that out. Okay? So we want to memorize that tonight. We want to know where all 6 of our trig functions are positive and negative in each of those quadrants. All right? Now, we have worked on the inside of the unit circle where we've gone through and figured out where all of the degrees and the radians come from. We want to spend some time today working on the outside of the unit circle. The first thing that I want to point out to you is that you only have to know 6 values and you know the whole outside of the unit circle. Let me show you what I mean. If you'll notice, if you go 30 degrees away from the x-axis, so basically we're making like a 30, 60, 90 triangle right here. If you go 30 degrees away, you're going to have the ordered pair square root of 3 over 2, 1/2. If you go 30 degrees away from the x-axis over here, because that would also make a 30, 60, 90 triangle, you'll notice it has the same ordered pair, square root of 3 over 2, 1/2. It's different. It's like positives and negatives changed. Okay, we'll come back to that in a second. But for right now, the numbers are the same, right? Triangle just, it's like I had the triangle and it just got flipped over. It got reflected over here. So I still have that same 30, 60, 90 triangle. It still has the same lengths. It's just that they may be going positive or negative, okay? If I come 30 degrees away from the x-axis, there's that same ordered pair, square root of 3 over 2, 1/2. If I come 30 degrees away from the x-axis, there's that same ordered pair, square root of 3 over 2, 1/2. You'll also notice that the radian measure that goes along with each of those, every one of those has a denominator of 6. 1 pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So all the radian measures on the unit circle that have a 6 in denominator have that same ordered pair with them. All right? We would notice something similar about 45 degrees. If I go 45 degrees away from the x-axis, the ordered pair that I get is square root of 2 over 2, square root of 2 over 2. And that's the same if I go 45 away into the second quadrant, or into the third quadrant, or into the fourth quadrant. And you'll also notice that every radian measure that has a denominator of 4 has that same ordered pair. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All of those on my circle. All right? Then the last one, 1/2 square root of 3 over 2. If I go 60 degrees away from the x-axis in any one of my quadrants, you'll notice that I also get that exact same ordered pair. And every one of the radian measures on the unit circle that have a denominator of 3 will have that ordered pair. So 1 pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So if I just knew those 6 numbers, those 3 ordered pairs, I would literally know the whole outside of the circle, right? Okay, but they still got that plus and minus thing going on, like the signs keep changing. How am I supposed to know that? That goes back to what we were just doing a second ago. Because what we just said a second ago was ASTC. A, in the first quadrant, all of them are positive. Cosine is the same thing as x. Sine is the same thing as y on a unit circle. So both of those are positive. And sure enough, if you'll notice, every single one of these sine and cosine values was positive. All right, go to the second quadrant. All students, S. Sine is positive, cosine is negative. And so sure enough, you'll notice that every one of our x values, our cosine values, are negative. And every one of our sine values, our y values, are positive. In the third quadrant, it's T. Only tangent is positive. That means that sine and cosine are both negative. And so sure enough, you'll notice all of these values are negative. And in the fourth quadrant, C, only cosine is positive, sine is negative. So you'll notice your x values or your cosine values are all positive. Your y values or your sine values are all negative. So that'll tell you whether you're supposed to use positives or negatives And so again, that takes us down to, if we just know those three ordered pairs, we'll have the whole circle. Now, most people don't seem to have too much trouble remembering this middle ordered pair. Square root of 2 over 2, square root of 2 over 2. That one's in the middle every time. It's pretty easy to keep straight. They also recognize that square root of 3 over 2 and 1/2 always go together, but they flip-flop. Like here the square root of 3 over 2 comes first and the 1/2 comes second. Here the 1/2 comes first and the square root of 3 over 2 comes second. And that's what we have the most trouble keeping straight. We get those backwards all the time. So let's talk about a couple of ways that we can keep that straight. Number one, you literally can just use common sense and plot the point. Let me show you what I'm talking about. Square root of 3 over 2, if you throw that in your calculator and you get a decimal for that, that's 0.866. That's basically like 0.9, right? Almost all the way to 1. So if I'm working on a unit circle where this radius is 1, if I take this point and I trace it straight down to get its x value, or I trace it straight over to get its y value. Let's say I'm thinking about the x value. I'm trying to figure out, is that x value square root of 3 over 2 or 1/2? I can't remember. Well, if I trace it straight down, see how that's almost all the way to 1 right there? If I'm trying to figure out, is that 1/2 or square root of 3 over 2, 1/2 would be like way over here, right? That's got to be square root of 3 over 2 for the x value. And if I take this and I chase it straight across to my y-axis, you can see how that literally is like halfway up that line. That y value would have to be 1/2. It's not like way up here at 0.9. I could do the same thing with the other one, with the 60-degree angle. If I take that 60-degree angle and I literally take that point and I trace it straight down, see that's about halfway down that line, so the x value is 1/2. If I trace it straight over, see how it's almost all the way to 1? That's got to be 0.9. That's got to be square root of 3 over 2. So that's one way we can do it, just by literally looking at the points and using some common sense. But this is probably my favorite way. If I look at that first quadrant, if I start with my y value of 0, if you'll notice, my numerators are going to count straight up. 0, 1, 2, 3. If I start with my y value of 0, my numerators count straight up. 0, 1, 2, 3. Same thing happens with the x values. If I start with this 0 in my x values, 0, 1, 2, 3. All the denominators are 2's, right? So that's not anything I have to remember. So if I just figured out how to get the 3, 2, 1, 3, 2, 1, all my denominators are 2, I've got that whole first quadrant, right? And once I've got that first quadrant, then I've got the whole circle. All right, so now that we've got a little better handle on the ordered pairs on the unit circle, let's look at some of the examples from 4-4. Example number 1 says, let negative 3, 4 be a point on the terminal side of theta. So again, first time we've seen a negative x or y value to contend with. So find the sine, cosine, and tangent of theta. All right. So can I assume that sine is 4 and cosine is negative 3? Can I assume sine's the same thing as y, cosine's the same thing as x? All right, I'm getting yes and no. When is sine the same thing as y and cosine the same thing as x? When you have a unit circle. A unit circle has a radius of, does this have a radius of 1? No. That's a 3, 4, 5 triangle, right? If you didn't happen to recognize it as a 3, 4, 5 triangle, you can come over here and do Pythagorean theorem and find out that it's a 3, 4, 5 triangle. That does not have a radius of 1. If it doesn't have a radius of 1, sine is not the same thing as y, cosine is not the same thing as x. That is the number 1 most frequently missed question on this test. Okay? So put a star by that, highlight it, something. People just automatically assume every time they see sine, that's y, and every time they see cosine, that's x. It is only when you're working with a unit circle when you have a radius of 1. So watch out for that. Now, we've mentioned how to figure out where x and y are positive and negative, but we haven't said anything about how to figure out where my radius is negative or positive. That's because a radius is always going to be positive. A radius is a genuine distance from the center of the circle to a point on the circle. It will always be positive, so I won't have to worry about it. So this is going to be a positive 5 for our radius. Okay? So now we've defined x, y, and r. We can go back and use our definitions for sine, cosine, and tangent. All right? So definition of sine is that it's y over r. So we can say, okay, sine is y4 over r5. So our sine is going to be 4/5. And again, definitely not the same thing as, like we saw a second ago, would our sine just be the same thing as our y value? No. All right, how about your cosine? What's your definition of cosine? X over r, right. So if I'm doing x over r, I can do x negative 3 over r5, and I'm going to get negative 3/5. All right, how about definition of tangent? Opposite over adjacent, or in terms of x, y, and r? Y over x. So let's take our y value of 4 over our x value of negative 3, and we'll have negative 4/3 for our tangent value. All right, look at another one, example 2. Example 2 says, given tangent is equal to negative 5/4 and cosine is greater than 0, find sine and secant. Given tangent is negative 5/4 and cosine is greater than 0, find sine and secant. Okay, I know that tangent is y over x. The problem is, I don't know where the negative goes. Like, it could be a negative 5 over a positive 4, or it could be a positive 5 over a negative 4. I'm not sure whether it's the x or the y that's negative. That's why they had to give me that extra piece of information that they told me cosine is greater than 0. That's how I'm going to figure that out. Okay, so let's think about coming back up here to the chart that we built. In what two quadrants is cosine positive? 4 and 1, all right? Then we also know that tangent is a negative 5/4, right? That was a given. So in what two quadrants is tangent negative? 2 and 4. So what quadrant am I in? 4. Look at that one more time. They told me that cosine was greater than 0. That only happens in the first and the fourth quadrant. They also told me that my tangent was a negative 5/4. Tangent is only negative in the second and the fourth quadrant. So I'm trying to figure out where both of those things happen at the same time. That's only the fourth quadrant. That lets me know I'm working in the fourth quadrant. If I'm in the fourth quadrant, I know sine is negative, cosine is positive, and tangent is negative. So I'm just going to put that down here so I have it for reference. Okay? So that means then that if I'm trying to figure out which one of these is positive and which one's negative, if I'm in the fourth quadrant, x is positive in the fourth quadrant and y is negative in the fourth quadrant, right? So that's how I can figure out where the negative is supposed to go. All right, so now we're back to our definitions again. Sine is y over r. So we're going to put y over r. So this would have to be a 3, 4, 5 triangle, right? R is 3. If I got 4 and 5, then the other one has to be 3, right? The hypotenuse has to be the largest side. You cannot have a radius of 3, that's your hypotenuse. You can't have a radius of 3 if your other sides are 4 and 5. The hypotenuse has to be the 5 on the 3, 4, 5 triangle. So watch out for that because they'll try and trick us with that. Okay, so if I have x and y, I'm just going to use Pythagorean theorem, x squared plus y squared equals r squared. So we'll say x squared plus y squared equals r squared. And we'll get r is plus or minus the square root of 41. Which one is it, plus or minus? Plus, how come? It is a distance. The radius is always positive. X and y can be positive or negative, but the radius is always positive. Okay, so now we can go back to sine is y over r. And y was negative 5, and r was square root of 41. And of course, we'll rationalize that. So instead of leaving the radical in the denominator, we'll multiply top and bottom by the square root of 41. All right, what's our definition of secant? All right, and in terms of x, y, and r? All right, so we're going to have, yeah, r over x. So square root of 41 over 4. Perfect. Now, I am horrible at careless mistakes. That is why I give you partial credit on every single problem, on every single test all year long. Because if you drop a sign, it should not be the whole problem is wrong, because I do stupid stuff like that all the time. I get that. So anytime that I can find a way to minimize my careless mistakes, I want to do that. And here's something that really helps me. You don't have to do this, but it's something that really helps me. You can determine your signs based on your quadrant at the very beginning of the problem, like we did, or you can wait until the very end. Because what happens to me is I get so busy over here with remembering my formula for sine and plugging in the right values and then rationalizing. Somewhere in there I'm going to drop that negative that I had, and then I'm going to get it wrong. So what you can do is you can go through in the very beginning here and go x is 4, y is 5, Pythagorean theorem, r is square root of 41. I don't care which one's positive and negative. I'll figure that out in just a minute. And you can go through and get your 5 square roots of 41 over 41 and your square root of 41 over 4. Sometimes they make us find all 6 of them, right? So I can go ahead and get all of the numbers and then go back to what we figured out over here. And at the very end say, okay, my sine has to be negative, so let me throw a negative in front of this guy. My secant is the same as cosine. It has to be positive, so I'll leave that one positive. If I check it at the very end, then there's less likelihood of me dropping a sign somewhere or making a mistake. Okay, so just a suggestion, but you could do what you like to with that. Okay, forget trigonometry for just a second. If you start at the origin, 0, 0, and you go over 1, what is that ordered pair? 1, 0. If you start at the origin and you go up 1, what is that ordered pair?
0, 1.
How about this one if you come over 1? How about this one if you come down 1? All right, so we say that for tonight, you must memorize these 4 points off of the unit circle. But there's not really memorization, right? You just told me what they were from common sense. If you start at 0 and you go over 1 to the right or over 1 to the left or up 1 or down 1, you already know what those ordered pairs are. But you do need to know those ordered pairs, because if we put those in conjunction with the ones that we were working on earlier today, we'll have the whole outside of the circle, right? So let's go ahead and pick those up tonight so that we can spend some more time focusing on the other ones tomorrow. Those 4 angles, 0, pi over 2 or 90, pi or 180, 3 pi over 2, 270, those are called the quadrantal angles or the quadrant angles. They get their name because they're not really in a quadrant. Like 90 degrees is not in the first quadrant or the second quadrant. It's just the dividing line between those two. So it's called a quadrant angle, or some books call them quadrantal angles. All right. So for example number 3, they asked me to go through and define the sine and the cosine of those 4 quadrant angles. Because I know I'm on a unit circle, we've identified every one of these radii of 1. Because I'm on a unit circle, remember when your radius is 1, sine, which is typically y over r, becomes y over 1. It becomes the same thing as the sine value. So sine and y are the same. Cosine, which is defined as x over r, when the radius is 1, becomes x over 1, or just x. So cosine and x are the same thing. So when they ask me what's the sine at 0, literally I can just say sine and y are the same thing, so that would be 0. What's the cosine at 0? Well, cosine and x are the same thing, so that would just be 1. All right, how about pi over 2? What's the sine at pi over 2? 1, good. What's the cosine at pi over 2? 0. So go ahead and fill in those last 4 values there. Go ahead and find the sine and the cosine of pi and the sine and the cosine of 3 pi over 2. All right, so what'd you get for sine of pi? Sine of pi. Is it the x value or the y value? Y. So what's the y value at pi? 0. How about cosine at pi? Good. Sine at 3 pi over 2? And cosine at 3 pi over 2? Good.